My name is John Rinaldi, and I'm here today to talk about DeviceNet. This is kind of a simple introduction of the 6.5 things that are very important for you to know about DeviceNet if you're not familiar with that technology at all. DeviceNet is one of the best ways to connect to a ControlLogix or a Rockwell Automation architecture system. It's a CAN-based system, and here's the things that you need to know about it. Number one, you need to know that DeviceNet is object-based. That means that the external view of every device on a DeviceNet network is that device looks like a set of objects. There are two kinds of objects. There are required objects, and there are application objects. There's actually some other ones, but we'll skip the rest. So you have a set of objects. Required, the identity would be one of the prime objects that you find in every DeviceNet device. The identity, an object, is simply nothing more than a collection of like data. Identity object, what is that? Things like date of manufacturer, vendor ID, serial number, all the things that describe the device, model number, the string name, things like that. There's also a DeviceNet object. The DeviceNet object has things like the DeviceNet MAC ID. That's the address on the bus, the MAC, the baud rate that's being used, and everything concerned with the DeviceNet. So those are required objects. You have application objects. If you're implementing a flow controller, you might have a temperature object that has the temperatures that you measured. You might have a flow object that has the flow, the current flow that's being measured. So you organize your data in a DeviceNet device in terms of objects with attributes for each of the data items within those things. Now that's not how you do it in software. In software you can do it any way you want. It's just the representation to the network is this object-based. That's number one. Number two, second item that we have to talk about. Number two is going to be the messaging. There's two types of messaging. There's explicit messaging, and there is cyclic or I/O messaging. Cyclic or I/O messaging. Explicit messaging is a message goes right to the object and says, I want to read or write a object64 attribute 2, something like that. You can open up the packet and you can see what's in the packet, and that's an explicit message. I/O message, on the other hand, is just bits. Both sides have to understand the contents of that bit. The PLC sends some outputs out to the device. The device knows what every bit in that packet means. The device sends data back to the PLC, and the PLC knows what every bit in that. There's no header information. There's nothing to indicate what that data is. They both mutually understand it, also called implicit data, to distinguish it from the explicit data. So the two kinds of devices, the two kinds of message types are the second thing you have to know about this. Third thing you should know. Third thing you should know about DeviceNet is that it's part of SIP. SIP is the Common Industrial Protocol. That means this object-based structure, this messaging, is really what SIP is SIP. That's the same for ControlNet, CompoNet, Ethernet IP, and DeviceNet. All use the same object-based structure and the same explicit and implicit messaging. When you send those kinds of messages over the ControlNet physical wire, you get ControlNet. When you send them over Ethernet, you get Ethernet IP. When you send them over CAN, which is the basis for DeviceNet, then you get DeviceNet. So it uses the same object structure, the same messaging. That's what SIP is. So SIP is the guts for all of these things. SIP is owned by the ODVA, and they maintain the specification for all that. That was number three. Okay, what's the fourth thing that you have to know about that? Fourth thing you have to know is, as I've already referred to it, is that it's part of CAN. CAN is a generic, cheap, easy way of communicating in an industrial network. It was created by Bosch in Germany. Bosch wanted to get all of the wires out of a car, so they needed something that they could easily move data around a car. They came up with this CAN network and created these little chips that could easily move data around a network. Rockwell brought that technology to the US and has used it in industrial automation and made it the basis for DeviceNet. So CAN is the physical network that moves data around. Now, the key thing about CAN is when you go to implement a DeviceNet device, there's a bunch of registers that control the timing on this network, and that timing has to be absolutely precise. If you get those registers wrong, your DeviceNet device will work kind of. It'll work most of the time. And you know what I mean if you have a device that works most of the time. It means that you're going to be up at 3 in the morning trying to figure things out. So you better get those CAN registers done right. That's why you want to use a provider like Real-Time Automation. Another thing, there's a bunch of operational issues that are very important for implementing DeviceNet. You have to understand what those are. There's LEDs. There's a spec for how to use LEDs. Customers love LEDs because they can walk down their line and see that all the DeviceNet devices are connected. There's also switches that some people use to set the addresses, and there's a specification for how to implement those switches. So there's a whole bunch of operational issues that you need to understand if you're going to implement a DeviceNet device. You have to think about whether your device is going to be non-isolated or isolated. And I tell you, a lot of people get this stuff screwed up. If your device has been connected to somebody else's power, you don't want that power getting mixed up with the power on the network. Because if you do that, you're going to end up with ground loops, you're going to end up screwing the whole thing up, and you could blow up all the devices on the network. Now, if you go isolated, there's a whole bunch of software issues that come into play with that you've got to be very careful about. So this is a big decision that you have to make, and you have to decide what you're going to do, how you're going to implement this, and you have to make sure you implemented it properly. 6.5, pick a provider properly. You need somebody who really knows the DeviceNet specification, who knows how the hardware works, can verify that your hardware works, that your hardware is designed right, whether it's isolated or non-isolated. Real-Time Automation is the kind of company that can help you with that. We can give you a daughter card, we can give you software, we can give you a off-the-shelf gateway module. No matter what you need, Real-Time Automation can help you. So that's a quick, short introduction of the 6.5 things that you need to know about DeviceNet. Have a great day.